Factor labeling worksheet number 2. Question 1. The following information is given in a science supply catalog. 60 rubber stoppers are equal to 500 grams, which costs $4.89. Each student in the class will need 4 stoppers. There are 24 students in the class. What mass of stoppers must be ordered and what will be the cost? So we have 24 students. Each student needs 4 stoppers for every student. The stoppers have a mass of 500 for every 60 stopper. And there is a cost of $4.89 for every 500 grams of rubber. So students will cancel out, stoppers will cancel out, grams will cancel out, and we're left with dollars. So we do 24 times 4 divided by 1 times 500 divided by 60 times 4.89 divided by 500. We are left with $7.824, or just about $7 with 82 cents. Number 2. You work for NASA and want to compare your car's speed to that of the space shuttle. If your car travels 55 miles per hour, what is the speed in kilometers per second? So we have 55 miles per hour. In 1 mile, I have 1.60934 kilometers. Miles will cancel out and I'll be left in kilometers. Now I need to transfer hours to second. In 1 hour, I have 360 seconds. 3,600 seconds, sorry. Hours will cancel out and I'll be left with seconds. So my units will be kilometers per second. Kilometers per second. So I do 55 times 1.60934 divided by 3,600, and I end up with 0.024 kilometers per second. My original had 2 sig figs, so that's what I'm going to do. It's actually 7 on the paper, I don't know why. Alright, 8. This one's a little bit complicated. A house flea weighs 25 nanograms. You go to the store and buy your mom 5-pound bag of fleas. The bag is on sale for $29.99. What is the price per flea? So what I've decided to do is transfer the nanograms into grams and then to pounds, and then just divide by the cost of 5 pounds. So I'm going to do 2.5 times 10 to the 1 nanograms. I'm going to multiply that by, in 1 gram, I have times 10 to the 9 nanograms. Get rid of nano. I know that in 1 pound there are 454 grams. And I know, now I'm canceling out grams, I'll be left in pounds. I know that the price is $29.99 for every 5 pounds. Pounds cancel out and I'm left with cost. Alright, so I'm going to do 2.5 times 10 to the 1 divided by times 10 to the 9. We're multiplying by 1, but it doesn't matter. So I'm going to, from 1, subtract 9. Then I'm going to multiply by 1 and divide by 454. And then multiply by $29.99. Then divide that by 5. You're doing this in the calculator. You get 3.3 times 10 to the negative $10 per flea. 9. Large bridges have to be built with an expansion joint so that they do not crumble during temperature changes. Normally, a certain bridge is 0.923 kilometers in length. At the coldest temperature, the bridge was designed to expand up to 0.924 kilometers on hot days. If the bridge increased in size by 36 inches on the hottest day of summer, is still within its design parameters. So first, let's find out what the parameters are. So it can go from 924 to 0.923. So it has a parameter of 1 times 10 to the negative 3 kilometers, right? So our number has to be smaller than this. All right, let's do 36 inches, 2 kilometers. I have 36 inches, and I have 1 meter having 39.4 inches. Inches will cancel out, and I'll be left in meters. I want to get rid of meters, so in 1 kilometer, I have 1,000 meters. Meters will cancel out, and I'll be left in kilometers. That's what I want, so I'm going to do 36 times 1 divided by 39.4 times 1 divided by 1,000. That gives me 9.1 times 10 to the negative 4. This is a much smaller number than that, so yes, we are within parameters. 10. If 1,500 white blood cells are lined up side by side, they would form a row of cells 1 inch long. What is the average diameter in micrometers of a single white blood cell? And it tells you that 1 inch is equal to 2.54 centimeters. All right. 1 inch is equal to 2.54 centimeters. So I'm going to start off with that because that's 1 inch already. All right, I'm going to go from centimeters to nanometers. So 10 to the 6. Sorry, not nano, micrometers. 10 to the second centimeters. This cancels out centimeters. And the reason I'm doing this is we could subtract and say that in 1 centimeter there are times 10 to the 4th micrometers, but we can just plug them in. This will be times 10 to the 0. So we'll do 0 plus 6 minus 2. That is going to equal times 10 to the 4 micrometers. And we have 2.54. That didn't change. We have that many micrometers, and it's saying that this is the measurement of 1.5 times 10 to the 3rd, 1,500 white blood cells. So if we divide 2.54 by 1.5, we'll get 1.7, and then we're going to do 4 minus 3 times 10 to the 1 micrometer. So the length of one white blood cell will be 17 micrometers. 11, last one. Eggs are shipped from poultry farms in trucks. The eggs are packaged in cartons of 1 dozen eggs each. The cartons are placed in crates that hold 20 cartons each. The crates are stacked in the trucks 5 crates across, 25 crates deep, 25 crates high. How many eggs are in 5 truckloads? So there's a mistake in my key. I forgot to talk about the 5 truckloads. So this is a issue with volume. So we're going to do 25 crates times 25 crates times 5 crates, right? Because it's 25 deep, 25 high, and 25 across. So that'll be my volume. That's my length times width times height. That is equal to 3,125 crates. All right. If 1 crate is equal to 20 cartons, and 1 carton is equal to 12 eggs, I can cancel out my crates, I can cancel out my cartons, and I'll be left with eggs per truck. So I do 3,125 times 20, and then that times 12, and that'll equal 7.5 times 10 to the 5, or 750,000 eggs. That's for 1 truck. but I have 5 trucks. So I'm going to multiply that by 5. And that equals 3,750,000. So I could say 3.75, and we do 1, 2, 3, 4, 5, 6 times 10 to the 6. And there you go. We could always round this to about 3.8 times 10 to the 6 eggs in 5 trucks. Alright? In 5 trucks. There we go.